Hello there. First thing first, where credit's due. I need to give all the credit. I cleaned the piece up where I give credit to. Most of the credit goes to Dr. Sanchez. He typed everything. He made everything, here. Everyone else is things I learned from them correlate to understanding things here. Yeah. The first thing I need to talk about is shock reflection at a solid, there's a wall and things reflect, right? And what does that really yeah, let's put it this way. It has to be parallel. It has to be parallel to so basically, look over here. This is parallel to this wall, right? Yeah, that's basically it. And over here, you see that this is parallel to this. Over here, between over here is also parallel. And kind of see what I mean over here with the parallelness of everything. And then you get it, I think, hopefully. This over here is called a Mach, I think it's stem. Yes, Mach stem. And this is a tangential discontinuity that appears. So what does this really show me? Okay, so this shows me that this solution is 100% possible, which makes perfect sense. Anyways, but what happens when it's not possible? What that means is a Mach number across this thing is too small. How do you explain it? The normal doesn't affect. So basically, what's happening is that if you look at this over here, the velocity over here, and what the normal is what matters, and it keeps on getting the x-axis will be the same. So if this is decomposed like this part will follow through. So this part will be this big, and then this over here would be followed through the same. We'll give you two different. This is Mach 2. And the same thing appears over here. But what's happening over here is that there's no solution. No matter what angle you try to do, the corresponding Mach number on the other side is not above 1. Therefore, no. Does that make sense? I hope it does. Probably not. I need to get a better way to explain that. But I think this example over here illustrates it, I think. So an example, let us assume that the initial shock analyzed so that Mach 3 and Mach angle of 20, like the deflection angle, which is, I believe, if I remember correctly, there's two angles. And let me just clean this up and then explain what the two angles are. Because did I explain the two angles? I'm not sure, but I will do it right now. So if there's a shock wave, the incoming angle over here is a B. What was it called in Greek? Beta, 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 beta. I think it's beta. Over here is delta. I always get confused with all these gammas, alphas, and things. Literally, I keep on confusing alpha with it's Greek letters. Uh, I should really memorize the names of them. I should do it right now. Let me do it on top of my head because memory is key. So this is delta. This is delta. This is lambda, I believe, actually. This is beta. This is alpha. This is omega. This is omega small. I don't know what this is. I think that is zeta. Is that all? I hope I got it correct. I probably didn't, to be honest with you. I'd be shocked if I got all the naming correct. Anyways, I'll double check that later. And over here, basically what happens is that it looks like M2 equals 1.996 over here. And these are given. Follow the calculation procedure correlated to get the shot. It follows that beta 2. And it goes like this. And did I screenshot the next portion? No, I need to screenshot that. Let me get the next portion because apparently I forgot to screenshot the next portion. Which fair enough. I'm a human. I make mistakes. That's part of life. I didn't know that. Okay, there you go. Okay, I can't believe I forgot to screenshot the next part. I don't think that's all. No, that's all. Okay, good. Okay, I didn't mess up so badly. So what does this tell me? So this is inclination of this one over here, which you can kind of see how to get because this is beta afterwards, right? This beta is apparently 53.57. How did someone get that? Well, in my opinion, what happened probably was this delta was found, right? Delta equal 20. And if I remember correctly, there's a big table that I can use. Let me see which table will tell me that. Is this one? Let's see if I remember how to use this. It's been a long time, a genuinely long time. So we start with delta, right? We said delta equals 20, right? And then what was the Mach number? I don't quite remember. So let me look back at it. Mach number was 3. And how do I use this again? 3 over here, going all the way down like this. And do I use the Mach oh, I think I use the Mach number after, don't I? I don't use the Mach number before, right? Am I tripping here? Let me check. We can check right now because the solution is given, so we can just check which one is actually used. So that looks like this, and then we can check which one of the two is supposed to be MD or MU is what I'm trying to figure out. We can easily figure out by looking at what Dr. Sanchez gave as his, the answer. Okay, the answer was about 50, so this is wrong. So it must be the Mach number afterwards, which it means as MD. Oh, it says it right here. I'm a little bit moronic there. That was a little bit moronic for me. Well, then it is about this range over here, right? I think he said it was like 1.99999 something, right? I think my brain is a little foggy today. I hope I'm not wrong. If I'm wrong, then this is gonna be embarrassing. Hopefully I hope I'm not wrong. So over here is about here. About here, right? About here, a little bit under. So I'm shaking hands. Oh, this is not my best work. There we go. There we go. There's 50. What is that? I can't read that. What is that? Is it 52 or 53? Something like that. 53. Okay, let's see if that's what the professor said. Yeah, about 53. Yeah, okay, okay. So we got 50. We got that answer at least. With that, we have Mach number two, right? So Mach 2 sine of 53. And this, I don't have a calculator, but I trust that the Dr. Sanchez writing is good and perfect. So we're just going to say that's correct. But I'm an engineer. I'm supposed to be skeptical of everything, and I cannot do that because I'm an engineer, and I refuse to do that to myself. Okay, let me get Desmos out and do it. All right, I'm an engineer. I can't not double check everyone's work. That's what an engineer does. That's the spirit of engineering. And then, oh, I almost put radians degrees. I get 1.59. Okay, that's all right. That's about right. Yeah, that's about right. Yeah. Okay. Well, I'll let coffee over myself. Anyways, with that said, I get 1.59. What is this? What is 3? Oh, 3 is over here. So that is another normal. Oh, golly, we have to figure this out. So so uh what that is second over here, right? So we have 20 degrees over here, right? And this Mach number of 2 is 2, but we need a Mach number at the end, which is not given, right? And do I have to solve for it with the equations? Um, I think I have to. Okay. Which means I have to use the MD equation, which I'll double check because I'm an engineer at the end of the day. So I'm skeptical of everything. Or should be, at least. That's what engineers do. They always double check each other, making sure we didn't make a mistake on our math. That's what a good engineer should do, in my opinion. That's my opinion. I might be maybe I am being too, what's the word? I don't. What is the equation for this one? It should be that equation up over here. Let me grab it real quick for you guys. I don't see it all though. It's here. Trust me, I know it's here. Yeah, here it is. And I'm pretty sure this is air, so we should be. Maybe we'll stop at this because this is taking longer than I thought. I thought this would be fast and we can move on to like other stuff over here because I have it planned that we're gonna rederive all the small things, but this is taking a lot of time to make a video of. Um, well, I didn't expect it to take this long. So over here we have the equations for this. So what am I doing again? We are plugging it into here. Now, uh, now we know. Do we know this angle over here? I don't think we do. Well, golly. Is there like I think, oh, okay. We don't know this angle, so we have to actually go back to our equidistant again and figure out that angle over there because if I remember correctly, you have a degree over here, the 20, but that will give you we need a deflection of 0. So deflection is one of these. So it's one of these over here, one of the bottom ones over here. And now we need our Mach number. What would be the Mach number downstream? Oh, that's what we're trying to do. Oh, no, my brain's working again. I have a couple of like I'm caffeinated like crazy right now. So yeah, it makes sense that I am in a joyful mood right now. I love my caffeine, honestly. I'm addicted to it. Yeah. So what is our hey, don't we need a normal for this? Yes, we do. We need a normal for this. Which I'll show you the math. It works. So the professor is correct. I just don't. Wait, did I make a mistake here? No, the professor is correct. It works. My question is that how do you guarantee that this normal is the same that's this normal? Oh, I get it. Ah, how sneaky of you. How very sneaky. Think about it. This normal must be the same as this normal because the geometry, you go to here and here. You're going from here to here, planar. So by thinking like that, they must be the same because otherwise the geometry does, oh my God, that's devious. Yeah. Yeah, that makes sense. Oh my God. Wow. Because to make this even shape possible, that must happen because this is going from this to this. So the normal must be like same. Hmm, that's interesting. Same opposite. Like it must be like a V. It must be a triangular. That's a sneaky way. That's sneaky. I mean I don't I mean it took a while for me to understand that, but once you understand it, it's a very clever. I will give you that. That's check. We got that. Now, oh, we need to get M3, right? How do you get that? Uh, okay. I think there's an equation. Let me just. Can we just not? Can we just look at this thing and figure it out? No, because it's MD. It doesn't have. Okay, so I need to look up how to get that. I think it's in the notes in the book. Let me just. Okay. So over here we have beta minus delta, and we need to get beta and delta, and obviously, how do you get that? We clearly know this is zero, right? We know that's zero. We need to get beta, and now that we have our MD, which is 0.66. Where would that even be? It is, huh? What? That's just 90 degrees. That's just, oh, I guess that proves the point. That just proves the point. Um, oh, yeah. That just proves the point that this exists because it's basically almost 90 degrees. Yeah, okay, fair enough. There you go. I think there could, yeah, I think if you get, this just proves that it exists, I think, but I think there could be a version where this is smaller and shows this is subsonic. I think this is still in this area, I think. No, this delta must be the same. So this is area. Oh, so it does show that, right? No, this Mach number is still small. So it's still in here a little bit for now. Interesting. Okay. Okay. All right. So but it shows that smaller you get, it actually does happen. Fair enough. I was planning to do this, but I think we'll section this off for tomorrow, for later because I think I'm going to make this into one video and we'll do another video later on doing that shit. Got it? All right. Let's just leave this meeting.